Okay, so we will see a lot of questions involving ratios, proportions, percents, those kinds of things. Take a look at this question. In 1960, scientists estimated a certain animal population in a particular geographic area to be 6,400. In 2000, the population had risen to 7,200. If this animal population experiences the same percent increase over the next 40 years, what will the approximate population be in 2040? So, what do I need to do here? How would I start this?
You take 2000 minus 1960, which is 40, and then you take 7,200 divided by, or minus 6,400, which is 600. So you do 600 divided by 40. So that tells you how many more animals were born per year, and then you take that times 140 for the next 40 years.
Okay, let's try that. Does that work? You guys seem a little less confident in that. So what he's saying, we knew we started with this and we ended with this. So from 1960 to 2000, we had 40 years. And during that time, our population went from 6,400 to 7,200, which we increased then 800 animals. Okay. Do we agree with that part? But then I start asking about the percent increase. So it's not just like the number of animals. We need a percent here.
Yeah, that's right, because if it was, it's not a steady.
Right. It's not a line.
The more animals there are, the higher the.
So, any other ideas then? We need the percent that it went up over those 40 years, okay? Anytime you're talking about a percent, it's like the part over the whole. Our whole here was our original amount. How many animals did we originally start with? How many did we end with? 7,200. All right, divide those. We get 1.125. That is my percent increase. Okay, so now we are currently at 7,200. So to find out how many we'll have in another 40 years, you can take that times your percent growth. So 7,200 times 1.125, and we get 8,001. Now, the only reason this worked is because there was a 40-year gap from 1960 to 2000 and a 40-year gap from 2000 to 2040. So we know that every 40 years it's going, we have a 1.125% increase. So we just apply that to our current number of animals.
Would it be 1.125 per year? I guess so.
Calculations here. 25%. Anytime I'm using a percent in a problem, what should I change it to? A fraction, or you can do decimal. So you can either say 1/4 or 0.25. Of means what? Multiply. Of always means multiply. So 0.25 times 200. What do we get? 50. Okay, if I say 1.8 times 75%, what would I do for the 75%? do you do 11 over 15 as a percent? You have to divide them and multiply by 100, or move your decimal twice. So we get
73.3.
Yeah, depending on how many decimal choices our answer had. Okay, if I said 1.3 times 0.4, that gives me 0.52. What would that be as a percent?
52%.
Always move your decimal twice. Or multiply by 100. Okay, 150%. That would mean
1.5.
of is times 0.6. So if I do 1.5 times 0.6, I get 0.9. What would that be in percent form? 90%. Alright, so of means multiply. If you're using a percent in a problem, you move the decimal back 2. If you're trying to write your answer as a percent, you move it over 2. Multiply by 100. Okay, I want you guys to try this question. You can turn and talk to somebody about it, because the 15% is on the discounted meal. So the normal price is $18. How much would they pay for the early bird price? So you get 10% off. That means what percent do you end up paying?
16.
Okay, so you are paying, two ways of doing it. You could either calculate what the 10% is and subtract it off, or you could say, if I get 10% off, I'm paying 90%. So either way will get you there. So if you do your 18 times 0.9, you get the 1620. So that's how much you would end up paying. Now, your tip is 15%, so 0.15, of means times the discounted meal. So your discounted meal is 1620. You take that times 0.15, you get 243. So you actually end up paying your price plus your tip. That's $18.63. So try on those to break it down. Go step by step and write out your numbers, and I think that would help a lot. Rather than just looking at it and seeing a bunch of percents and trying to figure out what to do with all of them. Let's try another one. When 15% of 40, so 15%, 0.15, of means times 40, is added to 5%. What would 5% be as a decimal?
0.05.
Of, so times 260. So now we can just put this in our calculator. Does everyone agree with that? Alright, there's usually some basic probability questions on the ACT. Probability is basically a fraction. The numerator is the number of outcomes you want. So how many times does the right thing happen? The denominator is the total number of outcomes. Okay, so think about it. If I'm rolling a dice and I want an even number, how many even numbers are on a dice? 3. The dice has the numbers 1 through 6, 2, 4, and 6 are even. So there's 3 numbers I like out of how many total numbers on the dice? 6. So a 50%, or a 1 in 2 chance of getting an even. Okay, if I'm flipping a coin and I want heads, how many heads are on my coin? 1. Out of how many total options? 2. So 1 out of 2. So Herbie's practice bag contains 4 blue racquetballs, 1 red racquetball, and 6 green racquetballs. If he chooses a ball at random, which is the closest to the probability that it will not be green? So if it's not green, what can it be? So how many balls are the color I want? 5. Out of how many total balls in this bag? So 5 out of 11 total. So we get 0.4545, so 0.45 is the closest. Okay, a school admits applicants only if they are able to pass a written and an oral exam. Past records have shown that 60% of the applicants pass the written, and 80% of the applicants who pass the written pass the oral. There are 1,500 total. How many will be admitted? So first, let's figure out how many will pass the written. There are 1,500. How many of them pass the written? So 1,500 times 0.6 tells me 900 will pass that written exam. Then it said, of those who pass the written exam, so I'm talking about those 900, there is an 80% chance they pass the oral exam. So I have to take my answer times 0.8, and we get 720. I'm probably going to stop here. I don't think I have enough time to get through the last one. So we'll pick up with this tomorrow.